Okay, statistical functions. So we've seen the mean, and this is, I don't know if we talked about this one, but this, we trim, we don't include the highest 5% of the data in our vector, and we don't include the lowest 5% of data in our vector. So that's what that does. Sometimes you want to do that just because if you might have a really high point that's completely different than the other data, you don't want to include it in your calculation of the mean. And this is, we've seen this before, this is remove all the NAs so that otherwise the mean won't work properly. And then, so we have this, we have the median, we have the standard deviation, we have the variance, we have the mean absolute deviation, which you probably don't know, but it's not, you can look it up. We have quantile, so here's an example of that. Suppose you have a vector from 1 to 1,000, and then you take the quantile and you put in x to apply it to that vector, and this just means you want to know the piece of data which represents the 30th, this is 0.3 30th percentile score, and the 84th percentile score. So this is the 30th, it's about this is about 30% of the way from 1 to 1,000, and this is about 84% of the way from 1 to 1,000. I'm not quite sure why we have these numbers here, but I guess it's just the way it calculates it. We'd probably get the same thing if we tried it. So anyway, basically it's just that 300 and 840 are the 30th percentile score and the 840th percentile score. Okay, here we have vector 1 through 4. Take the range of that vector, and it gives us 1 and 4. So that's a little different than the standard definition of range. So it's just telling us the highest number and the lowest number. But then we can take diff range, and that's the more standard definition of range, which means you take the highest value minus the lowest value, which is the difference between that is 3. So diff 3 is what I would normally call the range of x, but in R it's ranges gives you the highest and the lowest value, and then diff gives you the difference between those. Okay, sum of x, we know that. The difference. Okay, it looks like this, what this does is, if you look at this function and we do diff f, we get this, which I guess is 5 minus 1, then 23 minus 5, and then 29 minus 23. So you get those differences. And this is with the lag equal to 1, which means you do this one minus this one. But I guess the lag equals 2 would mean you do this one minus this one, and you do this one minus this one. Okay, you can try that out. I think that sounds right. Minimum of x, that's just the minimum value of x within x. Maximum of x is the maximum value within x. And scale, centering is, scaling is a way to take remember when we discussed this problem, the problem that these, like the math scores, are very different kinds of numbers than the science scores, which are different from the English scores, because these are like maybe 80%, like percentage out of 100, and this is like a raw score, and this is some other raw score. So these are not really comparable. So we want to make them comparable. So we might want to turn these into percentages, for example, and also turn these into percentages. And then also, like if the average, after you converted these to percentages, suppose the average was only 50%, and here the average was 80%, and so then, say just for these two, then you'd want to make the means the same as well, possibly, before you combine all of them. So anyway, that's this one. this scale function does that kind of stuff, and we'll discuss in more detail how it works, but that's basically what we try to do with it. Okay, in the next video we'll look at these functions and how they're one way of just using them. So we'll look at this listing 5.1.